Today I talk about very most important topic. Okay, topic same but concept different. You understand? Gauss test. It is mathematics. Third same GATE, JAM, IIT. Okay, all is very most important. So next, it is physics. Okay, IIT, JAM, NEET, BSc. All is very most important topic. Okay, I explaining only what. Next topic is organism and population. Guess. Okay, comparative exclusion principle. Okay, just guess. So first I discuss about mathematics, next physics, next biology. Okay, let's go. First you understand guess test means guess test. Okay, mathematics. If summation of un be a series of positive terms such that an by an plus 1 is equal to alpha plus beta by n plus gamma n by np, where alpha greater than 0, p greater than 1, and r n okay is bounded. If alpha not equals to 1, then where alpha greater than 1, summation of an will be convergent, and less than 1, summation of an is divergent, will be divergent. Okay, alpha less than equals to 1. Next topic, where alpha is equal to 1. Okay, when beta greater than 1, then summation of an will be convergent. Next, when beta less than 1, then summation of an be a divergent. Next, okay, if alpha not equals to 1, then an by an plus 1 is equal to alpha plus beta by n plus gamma n by np. Limit, it is proved. Okay, it is proved. Next, limit n tends to infinite an by an plus 1 is equal to alpha using D'Alembert ratio test. So D'Alembert ratio test, I discussed about D'Alembert ratio test in previous lecture. Okay, next, summation of an will be convergent if alpha greater than 1, summation of an be a convergent if alpha less than 1. Okay, when alpha is equal to 1, test fails. If alpha is equal to 1, beta not equals to 1, an by an plus 1 is equal to alpha plus beta by n plus gamma n by np. Next, an by an plus 1 is equal to beta by n plus gamma n by np. Next, n into an by an plus 1 minus 1 is equal to beta plus gamma n by np minus 1. Next, limit n tends to infinite n an by an plus 1 minus 1 is equal to beta. Next, then the rabbit test. Okay, it is very most important topic. Summation of an be a convergent if b greater than 1, summation of an be divergent if b less than 1. Fails when beta is equal to 1. Okay, it is beta greater than 1, it is convergent, beta less than 1, it is divergent. Always remember. Next, an by an plus 1 is equal to 1 plus 1 by n plus gamma n by np. Okay, next, n into an by an plus 1 minus 1 is equal to gamma n by np minus 1. Next, limit n tends to infinite n into an by an plus 1 minus 1 log n is equal to limit n tends to infinite gamma by np minus 1 log n. Limit n tends to infinite gamma n log n by np minus 1 tends to 0. Okay, and this is applying by L hospital rule. Okay, it is applying by L hospital rule. Next, 0 less than 1 by using Born test. Okay, Born test. Summation of an will be divergent alpha not equals to 1, alpha less than 1 divergent, alpha greater than 1 the series is convergent. Alpha is equal to 1, beta greater than 1, it is convergent, beta less than equals to 1, it is divergent. Okay, next I discuss about some example. An is equal to an 2 square 4 square 6 square dot 2n 30 square. Next, 3 square 5 square 7 square dot 2n plus 1 square. Next, an plus 1. Okay, 2 square 4 square 6 square dot dot 2n তার square into 2n plus 2 তার square by 3 square 5 square 6 square dot dot 2n plus 1 square into 2n plus 3 square. Next an by an plus 1 is equal to this is by it is okay. Next 2n plus 3 square by 2n plus 2 square. Next 1 plus 3 by 2n that square by 1 plus 1 by n that square. Next 1 plus 3n 1 plus 3 by 2n square into 1 plus 1 by n minus 2. Okay, next 1 plus 3n plus 9 by 4n square into 1 minus 2n plus 3 by n square. Next 1 minus 2 by n plus 3 by n minus 6 by n square plus 9 by 4n square plus 3 by n square. Next 1 plus 1 by n minus 3 by n square. Next it is an by an plus 1 is equal to 1 plus 1 by n plus gamma n by np. Okay, it is alpha means 1 and beta means 1. Okay, here an will be divergent. It is Gause's. Okay, next example. Next example, an is equal to 1 3 5 dot dot 2n minus 1 and by 2 4 6 2n plus 2 to the power p. Next an plus 1. Okay, 1 plus 3 dot 5 1 3 5 dot dot 2n minus 1 into 2n plus 1 by 2 4 6 dot dot 2n plus 2 into 2n plus 4 to the power p. Okay, next an by an plus 1 an by n plus this is by this is okay an plus 1. Next an by n plus 1 is equal to 2n plus 4 by 2n plus 1 to the power p to the power p. Next limit n tends to infinite an by n plus 1 is equal to 1. Always remember. Next 1 plus 4 by 2n to the power p by 1 plus 1 by 2n to the power p is equal to 1 plus 2 by n to the power p into 1 plus 2n square minus p. Okay, next you understand 1 plus 2p by n plus p into p minus 1 by it is factorial 2 into 2 by 2n square plus dot dot. Next into 1 minus 2 by 2n plus p into p plus 1 by n factorial. Okay, 1 by 1 by 4n square. Next 1 into 1 by n 2p minus p by 2 plus 1 by n square and p into p plus 1 by 2 factorial into 4. Next 4p p minus 1 okay by n factorial minus p square. Next 1 plus 3 by 2 p into 1 by n plus gamma n by np. Okay, and alpha is equal to 1, beta is equal to 3 by 2p. Okay, it is beta and it is alpha. Okay. So next beta greater than 1 equation 3 by 2 p greater than 1 implies that 3p is greater than 2 p is equal to 3 by 2. The series is convergent. Okay, beta less than equals to 1 this is p less than equals to 2 by 3 it is divergent. Less than divergent and greater than is called convergent. Okay, so it is mathematics portion. Gause's or some example. Okay, it is Gause's limit a summation of an be a series of positive terms an by n plus 1 1 plus alpha by n plus beta n by np p greater than 1. Okay, bn is a bounded sequence. The series is convergent if alpha greater than 1 and divergent alpha less than equals to 1. Some example. It is problem. Okay, next understand. Test the convergence of the series. Okay. The given series is convergent p by 2 greater than 2 p greater than 2 divergent p by 2 less than 1 p less than 2. Okay, next I discuss about physics means Gauss law. The net electric flux through closed surface. Okay, some you understand it is closed surface. Okay, closed surface. The net electric flux through a closed surface 3D, okay, is 1 by epsilon naught times the net charge enclosed by a surface. Phi closed is equal to q net inside by epsilon naught is equal to closed integration E dot dA. Okay, so please you watching this note. Okay, first you understand electric flux phi. Okay, it is through some light and surface is a small e dA. D phi is equal to E dA cos theta and D phi is equal to E dot dA. Phi is equal to integration of D phi is equal to integration of E dot d A vector. Next phi is equal to E dot A and E it is constant. Next Gauss law. The net electric flux through closed surface 3D is 1 by epsilon naught times the net charge enclosed by the surface. Phi closed is equal to q net inside by epsilon naught, okay, is equal to integration of closed E dot dA vector. Okay, next some example. It is sphere. Okay, it is r radius and dA theta is equal to 0. Okay, theta is equal to 0 and theta is equal to 90 degree. So next d phi is equal to E dA cos theta. D phi is equal to E dA cos 0 degree means E dA, and next d phi E dA cos theta is equal to E dA. Phi is equal to integration close integration d phi is equal to close integration E dA is equal to E close integration dA. Next it is closed surface. Okay, this part is closed surface, this part is sphere. Next phi is equal to EA 1 by 4 pi epsilon naught q by r square into 4 pi r square. So phi is equal to 4 pi r square, 4 pi r square vanish and q by epsilon naught. Okay, it is Gauss law. Next radius always 2r. This radius is 2r. Okay, and next is okay, phi is equal to 1 by 4 pi epsilon naught q by 2 r square into 4 pi 2 r square. Phi is equal to q by epsilon naught. Size of closed surface do not after net phi. Phi net q by epsilon naught. It is q net epsilon naught. Okay, q and it is net q by epsilon naught. Sphere of the closed surface do not after net phi. Okay. Next it is we know that phi is equal to q by epsilon naught Gauss law. Net charge inside. Okay, it is closed surface. Okay, it is Gaussian surface. Some example, it is outside. Okay, it is inside q1 q2 charge. The phi is equal to E1 dA cos 180 is equal to minus charge, and phi 2 is equal to E2 dA cos 0 degree is equal to positive charge, positive. Okay, so phi net is equal to 0. Next q1 q2 to charge and only inside charge. Okay, q3 result then the field due to wall charge. So phi is equal to q1 plus q2 by epsilon naught is equal to integration of d dot dA. Okay, next total closed surface. Gauss law is always applicable. Gauss law is always applicable, but not always. Okay, first is the Gaussian surface should be symmetry but charge distribution. Next is the electric field must be symmetry equal constant, same of all point of Gaussian surface. Okay, next elsewise all Gaussian's law is valid that not useful. Next, the theta angle between E vector dot A vector must be small at all point of the surface theta 0 and 90 degree, theta is equal to 90 degree. Next, Gaussian surface must not pass through any point charge. Next, I discuss about Gaussian surface must not pass through any point charge. Okay, next this is our very high concept and very most important topic, electric flux. So when E vector field lines cross a surface, then we say there is electric field phi E through the surface. Electric flux is surface integrations of electric field. The phi E is equal to integration of E dot ds. Okay, it is dot product, always remember. Okay, next 1 2 3, first directions of area. It is perpendicular, it is tangent. Okay, it is tangent. And flat surface, it is flat surface. Next, first case, theta is equal to 0. Second, third, okay, horizontal, vertical, and it is horizontal. Okay, it is horizontal. Okay, it is vertical. Theta is equal to 0 and horizontal. Phi is equal to 0, theta is equal to 90 degree, and it is second case. Next, phi is equal to integration of E dot ds cos 90 degree, phi is equal to 0. Next, Gauss law. Okay, the total electric flux through a closed surface is equal to charge enclosed by the surface divided epsilon naught. The phi E closed is equal to integration of E dot ds is equal to phi enclosed by epsilon naught. Okay, using Gauss's divergence theorem, integration of E dot ds is equal to phi E dot ds is equal to q enclosed by epsilon naught. Okay, it is closed surface. Okay, a closed integration. Next, I discuss about derivative from, it is integration from Gauss's theorem. And next, I discuss about differential from Gauss theorem. It is Gauss surface, wall charge, and surface volume. Okay, integration of a dot ds is equal to delta dot a dv, integration of delta dot a dv. Next, integration of delta dot e dv is equal to 1 by epsilon naught integration of p delta v. P means p, it is not p, it is rho. Okay, rho is equal to dq by dv, dq is equal to p rho dv, and q enclosed is equal to integration of p dv. It is delta dot e vector is equal to rho by epsilon naught. It is differential from. Okay, differential from of Gauss theorem. It is delta dot e is equal to rho by epsilon naught. Delta means d by dx I vector plus d by dy j vector plus d by jz k. Okay, dot e is equal to p by epsilon naught. Okay, this is delta. Next, divergent of electric of and use p at that. Okay, next some example. A sphere of radius r has uniform disturbed charge q is its value. Calculate divergent inside and outside. Okay, inside is delta dot e is equal to p by epsilon naught is equal to q by v epsilon naught. Okay, and it is delta dot e is equal to q by 4 by epsilon 4 by 3 pi r cube epsilon naught is equal to 3 cube by 4 pi r cube epsilon naught. Okay, 3. Okay, next, it is outside delta vector dot e vector is equal to 0. Okay, next, integration of e dot ds. Okay, integration of e dot ds is equal to q enclosed by epsilon naught. If q enclosed is equal to 0, then e vector may or may not be 0. Okay, e vector is equal to 0, may or may not be 0. Next, if q enclosed is equal to 0, then integration e vector is equal to 0 only for 3 cases. First is symmetry case. Okay, symmetry case, spherical symmetry. Next is cylindrical symmetry. Next is planar symmetry. So in this time I discuss about first is spherical symmetry. Okay, spherical symmetry, p is equal to constant only. Okay, it is spherical symmetry. Okay, p is constant, sigma is constant. They should not depends theta and phi. Okay, theta and phi, they should not depend theta and phi. Next, cylindrical symmetry. It is cylinder. Okay, it is cylinder. It is axis. It is r radius. Next, p is constant. Sigma is constant. Next, plane symmetry. Sigma always constant. Next, I discuss about some example. It is not symmetry case. Okay, it is phi includes 0, e not equals to 0. It is non-symmetry case. Okay, it is light passing in our surface area. Phi e sphere is equal to sphere. Phi sphere is equal to q enclosed by epsilon naught. Phi e sphere is equal to 0. We can that e vector will be 0. Next, some problem. This is calculate the flux through the area. Okay, calculate the flux through the area. So e vector ez axis uniform direction. Okay, next formula, phi is equal to integration of e dot ds. Okay, integration of e dot ds, magnitude z into z vector is equal to integration of e dot ds is equal to e into integration of ds is equal to e a square. Flux through the surface. Okay, next I discuss about biology. Next I discuss about organism and population gas comparative inclusion principle. The first, two closed relation pair comparating of same resonance, limited resonance, it is limited, cannot coexist independently and comparatively inferior one will be eliminated eventually. Okay, the first, promote coexistence, resource partition and multiplication. It is 5 related pair of Oebres. Next, competition, interaction between the sphere surrounding living on same resonance may be or two types. First is interspecial comparisons between individuals of different species. Next, interperative comparisons between individuals of same species. First is effect of comparison, long-term effect. Example, comparative exclusion principle occurs in logical time scale. Okay, logical time scale. Next, short-term effect. Example, character displacement operates on evolutionary times scale. Next, comparative exclusive principle. It is also known as Gauss law. Two species that compete for the same resource cannot coexist in same area. Considered some explanation. It two different species living in a same area and ensuring the same resource for the living, then there will be comparisons between both the species due to unstable cohesions. The capable or fittest species will be stable and exist in that environment. Some example, Paramecium aerulea and Paramecium cadonium. Gases determine the growth of each species in two different conditions. First is growth of species, calculate medium of other species, and next, mixed culture growth. Okay, it is day. Okay, it is day and it is population side. It is Paramecium aerulea. Okay, and Paramecium cadurium. Okay, and it is Paramecium aerulea. Okay, and it is Paramecium aerulea and Paramecium cadiotum. Okay, to both. It is day, it is population. Okay, next you understand each species when cultivated separately shows the typical growth patterns spirality through growth according to their ability to ensure the resource to cultive medium. Next, when growth together there is a decrease or paramecium calutrum populations and increase in the paramecium aurelia population. Next, inclusions. Close related species cannot coexist on single limiting resource for long times, and comparatively superior species is able to survive, whereas the weak one will get eliminated. Okay, next. Okay, paramecium aurelia and paramecium cadonium and paramecium berbecia. Okay, so thank you, take care, take curious, and thank you, take care, goodbye. Okay, thank you, take care, goodbye. Okay.